Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at partial differentiation. So that's where we have a function of several variables. Like this one here, f of xy equals x over x plus y. So partial differentiation, we're only differentiating with respect to one of the variables. So we usually write like this. This means partial derivative here. So the partial derivative of f with respect to x. Now you'll sometimes see that called f1 of xy. This little 1 means we're differentiating with respect to the first variable listed. So if I want to differentiate this with respect to x, I just treat y as a constant. So how would I differentiate this? I would need to use the quotient rule. So the quotient rule is derivative of the top times by the bottom minus the top times the derivative of the bottom. So the derivative of x plus y, treating y as a constant, it would just be 1. And that'll be all over x plus y squared. So if you expand these brackets, you get x minus x is 0. You're just left with y over x plus y all squared. So now let's look at the partial derivative of f with respect to y. And you'll see that written as f2 of xy. So that means we're differentiating f with respect to the second variable that's listed. So here, if we're differentiating with respect to y, we're treating x as a constant. So it would just be x times the natural log of x plus y. So we can also have higher order partial derivatives. So if I write d squared f over dx squared, this is telling me that we are differentiating this twice, both times with respect to x. So you might see this written as f11. You're differentiating with respect to the first variable and then with respect to the first variable again. So what I would do is I would then differentiate this with respect to x. So to differentiate this again, I would use the chain rule because this is just y times x plus y to the power of minus 2. Now remember, we're differentiating with respect to x, treating y as a constant. So we would just move the power to the front, decrease the power by 1, and we usually times by the derivative of what's inside, but it's just 1 here. So the second derivative both times with respect to x is minus 2y over x plus y cubed. So you also need to be able to differentiate ones like this. So this again says the second partial derivative of x, but this time what we're doing is we're differentiating with respect to x, then with respect to y. So we've already differentiated once with respect to x. We're now going to differentiate this one with respect to y. So if we differentiate this with respect to y, we would need the quotient rule. So quotient rule tells us it is the derivative of the top, which is 1, because we're differentiating now with respect to y and treating x as a constant. So it'll be 1 times the bottom minus the derivative of the bottom. So the derivative of the bottom is 2x plus y, and that's all divided by the bottom squared. So it turns out if we simplify this as much as we can, we end up getting x minus y over x plus y cubed. Turns out we would get the same answer if we switch the x's and y's around. So we differentiated this with respect to y first and then differentiated with respect to x. As long as the derivatives are continuous and the function is continuous, you'll always see that. When you're taking the second derivative and you're differentiating with respect to each of the variables, it doesn't matter the order in which you differentiate. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.